In Year 11, you've already seen the T formulae in your trig unit, and today we're using them to solve equations of this form, a sine x plus b cos x equals c. Now, in our last lesson, we solved equations like this using the auxiliary angle method, and we also used that method to graph functions. So we've got another method today of doing some of the same things. Now, one of the best things about this method is that it's often faster, and it only has one approximation. So all we really need to do is sub t equals tan of x on 2 into our equation, and it will reduce it to a quadratic equation. Now, when I say sub t equals tan of x on 2 in, what we're actually subbing in is these formulas here that are generated by this one. Now, these are written on your reference sheet, so you don't have to memorize them. Have your reference sheet sitting beside you while you're doing your exercise, so that way they'll get more and more familiar. Sine of x is equal to 2t over 1 plus t squared if t is equal to tan of x on 2. So here we've got a nice neat expression for sine of x and for cos of x. We probably won't be using this one for tan of x because we're solving equations of this form. But you can see here how we'll be able to substitute each of these in and then solve our equation. Now, once we've got a quadratic, we've got three ways we can solve those: factorise, use the formula, and complete the square. Now, the disadvantages of this method, the intuition about it being a shifted wave like a sine or a cosine curve is actually lost. So we can't use this method for graphing like we could with the auxiliary angle method. And the other big disadvantage is that if x equals 180 degrees is a solution, then this method will not find it. So you need to put some kind of big red box around this as a big disclaimer, something to really take note of. So why is this happening? Well, tan of x on 2 is undefined when x is 180 degrees because you can't find the tan of 90 degrees. That makes sense. So we can get around this by, if we're using this method, we could just check at the end whether 180 degrees could be a solution for x. And if it is, whack it in there. But what you're going to find is that x being 180 degrees is a solution when some particular things happen in the equation. So you're going to learn to spot it when the terms in t squared cancel and you're left just with a linear equation in t, or when the coefficient of cos x is opposite of the constant. So in either of those situations, what you end up finding is things are a bit funny and you're like, oh, maybe this is one of those ones where one of the answers is x equals 180. So let's have a look at how to do this. I'll give you two examples. Okay, now you might notice that this is the same question that we've solved before using the auxiliary angle method. So it's kind of handy to do it using this method so that we can compare the working of each and see which one seemed easier or which one seemed like your favourite. So we're working between minus 180 degrees and 180 degrees, and we've got a full period there, so all four quadrants, and we're using t equals tan of x over 2. Now all that means is that if t equals tan x over 2, then we can use those formulas sine x equals 2t over 1 plus t squared, etc. If we had a different angle here, and let's just say we had sine of 2x there, and it said using t equals tan x, we could still go ahead and use that same formula. But we need to just compare that, making sure that this angle here is double whatever that one is there. Okay, so first step, we can see that we've got three lots of, now sine of x is equal to 2t over 1 plus t squared. You can get that straight off your reference sheet, minus 4 lots of 1 minus t squared over 1 plus t squared equals negative 2. Okay, now you'll need to be careful here not to make a classic sign error because these come up all the time in these questions. The next thing to do would be to multiply all three terms by 1 plus t squared because that will get rid of the denominators over here. So on the top here we'll just have 3 lots of 2t, which is 6t, and we'll have minus 4 bracket 1 minus t squared, and you can keep that there and expand it on the next line if you like, or you can expand it as you go. Just remember, if you're expanding as you go, the minus 4 times the minus t squared will give us a plus 4t squared. And over here we've got minus 2, 1 plus t squared. And again, if you were expanding as you went, you could expand this as you went too. If you know this is an area you make mistakes, just write out the brackets and expand it on the next line. It really won't take you very much longer, and you're bound to save yourself quite a lot of mistakes. Minus 2 minus 2t squared. Now let's just gather everything up onto the same side so that we can solve our quadratic. If I add 2t squared to both sides, I've got 6t squared plus 6t, and adding 2 to both sides, I get minus 2. Now I can see that I can easily halve all of those terms just to make it a little bit simpler. Now I can tell straight away that I can't factorise this, because if I had something like, and I'm just sort of imagining this in my head, 3t and t here, and 1 and 1, I'm never going to get the 3 t's. So I can see I can't factorise it. So I think I'll reach straight for the quadratic formula, where I've got a equals 3, b equals 3, c equals minus 1. So I go minus 3 plus or minus the square root of b squared, that's 9, minus 4 times 3 times negative 1, all over 2a. And tidying that up, I can keep working down. If I like, I might just go along here, so I'm saving myself some board space. What do we have in here? We've got 9 plus 12, so we've got square root of 21. So I've got minus 3 plus the square root of 21 over 6, and I've got minus 3 minus the square root of 21 all over 6. You could write it with the plus or the minus. I'm just thinking through what I have here. Now, remember what t is. T is the tan of x on 2. So effectively, what we could say here is that the tan of x on 2 is equal to all of that. Now, see how just swapping that out saved me from rewriting a lot of things. Now, the tan of x on 2 could be a positive number, which this is, or it could be a negative number. But let's keep in mind what our domain was. Handy to go up here and say, if x has to be between these two, then x over 2 actually has to be between 90 and minus 90 degrees. So I'm actually only looking for the tan of something to equal either of these two. I'm only looking in the first quadrant and let's call it the minus 1th quadrant, the one that's over that side. So to figure out what x over 2 would be, I need to take the inverse tan of all this and the inverse tan of all of that as well. So after that, I'm going to have to then double my answers. So I don't want to round them off too early because then I want to round probably to the nearest minute once I get to here. So inverse tan of negative 3 plus root 21 over 6 equals 14.77. I'll just put a bunch of numbers down there. Now if I then double that to the nearest minute, I get 29 degrees and 33 minutes. Okay, now let's think through, would there be another quadrant answer here? If I've taken the inverse tan of a positive number and I've got this, then I know that tan is also positive in the third quadrant. Now the third quadrant answer would be 180 plus that number, so 180 plus 14.775 or so, that's 194, and when I double that, it's going to be way too big. So thinking through what I'm expecting x on 2 to need to be often means that I only want one of the quadrant answers there. But depending on your question, you need to think this through every time. So that's the only solution that's within the domain for this one. Now I need to go back, and if I hit my up button on my calculator, I can get back to the working where I did inverse tan of all of this, and now I can just change that negative into a, I can change the plus into a minus. And I get minus 51.645 or so. So that's an angle that I'm expecting. I'm looking for one between here and here. And when I double that and round it off to the nearest, I get nearest minute, 103 degrees and 18 minutes. Now, would there be another solution that I need here? Well, if the tan of minus 51 gives me a negative, then tan is also negative in the second quadrant, and the second quadrant version of that would be 180 minus that 51 or so, and that would be about 130. But when I double that, 260 is going to be too big. So see how just thinking through the rough numbers in your head can help you see whether you've got all the solutions. But I think that's all there is for this one. And now you can compare that to the working that you did in the last lesson when we solved this with the auxiliary angle method. This example is a little bit simpler, but it also has a trick to it. So we're working from 0 to 360 degrees, and we've seen that t equals tan of x on 2. So always just check that the angle that you have in here is double what this angle is here. If it is, you can go ahead and throw your t formulae straight in. So sine x is 2t over 1 plus t squared. So I'm just going to multiply 7 and 2t together in my head and get 14t. A little bit further ahead there. Then I've got minus 4 lots of 1 minus t squared over 1 plus t squared. It doesn't really matter if the brackets extend all the way or not there. And that equals 4. So you'll find you're doing the same first step a lot of the time. Let's multiply all three parts of the equation by 1 plus t squared. That will get rid of our denominators here. Careful not to make a classic sign error there. We have minus 4, we have plus 4t squared equals, and here I could expand this already in my head. I've got 4 lots of bracket 1 plus t squared, so I'm going to have 4 plus 4t squared. Now again, if you find that doing things in your head leads to mistakes, stop doing it, write out the brackets, expand them carefully. If you find that you're quick and you're not making mistakes when you're doing things in your head, go for it. All right, let's gather everything up onto the same side. Well, straight away I can see, look, the 4t squareds have cancelled. And that was one of the red flags that we were told to look out for, because when that happens, x equals 180 degrees is often a solution, and it won't drop out. We need to add it manually. So here we've basically got 14t is equal to 8. So t is equal to 8/14, which we can write as 4/7. Now, what does t equal? T is equal to the tan of x on 2. So at that point, we need to switch and say tan of x on 2 is 4/7. So x on 2 is the inverse tan of 4/7. Now, it's good always to think about your quadrants, but what you're going to do in this exercise is think about them and then go, oh no, it's okay, I didn't need to think about it. Still keep thinking about it because it just reminds you to be vigilant. If we're saying that the tan of something is positive, it's normal to think that we need the first and the third quadrants, and that we need to find the related x on 2, which will be the first quadrant answer, and then we would need to add it to 180 degrees to get the third quadrant answer. But have a look at what's going on up here. If x is between here and here, then x on 2 is actually between 0 and 180. So that's just the first two quadrants. So if we're saying the tan of something is positive, we actually only want the first quadrant answer. So we don't want the first and third quadrants. We just want the first one. Okay, so we can put that into our calculator now. And we need to find inverse tan of 4/7. Make sure you're in degrees mode. And we have, to the nearest minute, 29 degrees and 45 minutes. Now, I don't want to round off to minutes yet because I still need to multiply by 2. So let's just jot down a bunch of decimal places there in case we lose it, or just to show roughly what we have. And then we can multiply that by 2. And then we can go to the nearest minute, 59 degrees and 29 minutes. Okay, now we had our red flag up here, which should have reminded us to check for 180 degrees being a solution. Now, let's check whether it is or not. Literally, you can just type in 7 sine 180 minus 4 cos 180 and see what you get. 4. So yes, it is a solution, and we can add it in there manually, and we're done.